All right, we are going to wrap up with part three here, looking at the mole. All right, so we kind of already talked about this a little bit, but I want to explicitly mention it and have it here. Molar mass is the mass of one mole of a substance. So the molar mass of a few different elements can be found in the periodic table, and the number that we see as the atomic mass in the past is the same value of molar mass, just changing the units. Right? So once you understand that's the mass, it could be AMU per helium atom, for example, 4.003, or 4.003 grams per mole. And carbon atom, we've talked about that. So the molar mass of an element has the same numerical value as its atomic mass, but with different units, units of grams per mole. So the same thing we can do with molecules and compounds. The molar mass of a compound has the same value as the molecular mass, but with different units. So water from before had a molecular mass of 18.01 atomic mass units, also has a molar mass of 18.01 grams per mole, right? So this means molar mass is essentially a conversion between mass and moles, right? It's a conversion between the moles and grams of a substance. So we can kind of write another unit plan between moles and mass, and we have an equivalent statement here, which can be turned into um, a ratio. So 1 mole is equal to x grams, where x, it depends on the substance. Think back to our analogy of nails, right? 1 dozen nails was always 12, but the mass of a dozen depended on the size and type of nail. Here, Avogadro's number, or a mole, is always 6.02 times 10 to the 23, and that's a mole. But now the mass of moles depends on the substance, right? So here's a couple examples, example problems to work through. Calculate the number of grams of sulfur in 2.78 moles of sulfur. So this is something that you're going to have to look up, right? You have to look up the molar mass now of sulfur. So in the periodic table, we find sulfur, and it says 32.07, right? And so that could be grams per mole or atomic mass units per molecule. In this case, we're going to use grams per mole, molar mass. So start with the known quantity, 2.78 moles. By the way, MOL is often the abbreviation for mole, which is kind of funny because it's only one letter less, but MOL would be the mole unit abbreviation. And then now I want grams of sulfur to mole of sulfur, and that gives us 2.78 times 32.07, which is 89.2 grams of sulfur, right? If 1 mole is 32, then more than one, it should be more than 32. All right, let's do the second question. How many moles of carbon are in 0.58 grams diamond? So a diamond is pure carbon, by the way, and so that would be about a 3-carat diamond there. That'd be pretty big. So carbon, right, we know is 12.01 grams per mole. And so starting with the measured quantity of 0.58 grams carbon, I know that 1 mole of carbon is 12.01 grams carbon. And so canceling out grams, we get 0.048 moles of carbon. Now notice I've started to use the element as part of the unit because we might have cases where we have moles, like if we did water, for example, we'd have moles of hydrogen and moles of oxygen and moles of water to keep track of separately. So it's good to add that to your units as you're working through problems. Okay, so we've done a couple different things here that we can actually now put together. So putting it all together, we have a relationship between the number of particles and moles, which is Avogadro's number. And then we also have a relationship between moles and mass, which is the molar mass. So putting these together in a sequence, we have a relationship between the number of particles and the mass. Okay, just like the number of nails and the mass of the nails, number of particles and the mass of the substance. Now the conversion between number of particles and moles is always the same. That's Avogadro's number. And the conversion between moles and mass, the molar mass, depends on the substance. And we will finish up here with these last two questions, and then a couple multiple choice questions. All right, so why don't you read through these and take a few minutes on your own to pause and answer them, and then come back and hit play, and we'll go over it. Okay, so I've already worked through the answers on this slide, so I'll present it and then walk through it. Okay, so how many molecules of CO2 are there in a sample of dry ice with a mass of 22.5 grams? And dry ice is solid CO2. So first we need to find the molar mass of CO2, right? And then we'll use our conversion from grams to moles to molecules. And we find the molar mass by looking up carbon and two oxygens, adding those up to get 44.01 grams per mole. And then we'll take our mass, measured mass, times the molar mass to get moles, times Avogadro's number to get molecules, and that gives us 3.07 times 10 to the 23 molecules of CO2. In question 2, a normal dose of ibuprofen contains 5.84 times 10 to the 20 ibuprofen molecules. What mass of ibuprofen is this? And then the molecular formula is given as C13H18O2. So once again, first we need to find the molar mass, then we'll do the reverse, go from molecules to moles, then to mass in grams. So C13 is 13 times the molecular mass of carbon, plus 18 times the molecular mass of hydrogen, plus 2 times the molecular mass of oxygen, gives ibuprofen with the molar mass of 206.27 grams per mole. And we'll take the number of molecules, convert by dividing by Avogadro's number to get moles, multiply by grams per mole to get grams, and we get 0.200 grams, which is a 200 milligram dose of ibuprofen. All right, let's do a few multiple choice questions here to finish up. So select the correctly rounded molecular mass of hydrogen peroxide, H2O2. Okay, and the answer is, after you've paused it and answered this for yourself, 34.02. Right, so this is 1.008. This is 16.00. So when we add these up, we're only going to look at two places after the decimal, right? According to, there we go. According to our sig fig rules, so we would get 34.016, which is around to 34.02. Okay, what does Avogadro's number equal? Pause and answer for yourself. Okay, now that you're back, it is all of the above, right? 6.02 times 10 to the 23 units of anything, yes, which is also 1 mole of oxygen atoms, because 1 mole of anything, which is 16 grams of oxygen atoms, 16.00 grams per mole, and 1 mole of KCl formula units would be equal to Avogadro's number. So lots of different ways to think about Avogadro's number. How many moles of Cl chloride are present in 0.22 mole of magnesium chloride? Pause and answer for yourself and see that it is 0.44. So we can think of this as another dimensional analysis. We have 0.22 moles of magnesium chloride, and for every 1 mole of MgCl2, there are 2 moles of Cl minus, right? And so we get 0.44. Next question. A patient's blood test results showed 0.030 moles of CO2 per liter. How many molecules of CO2 are in 0.030 moles? So how many molecules per liter would be in this patient's blood result? So pause this, answer for yourself. And now that you're back, the answer is E, right? So a couple things happening here. Right, you're looking at sig figs and also the exponents, right? So once you do the calculation of 0.030 moles multiplied by Avogadro's number, okay, and you know that you're talking about molecules, it's gonna be a really big number, right? So A and B are out, right? They don't make sense. Plus you're forgetting the 10 to the 23 here, right? And then 0.03 would give us 1.806 times 10 to the 22, but sig figs, right? This number only has 2 sig figs, the 3 and the 0 behind it. So we only get 2 sig figs here. All right, last one. How many grams of water are present in 5 moles of water? Pause this and answer. Okay, now you've worked through it. You come back, and the answer is 90 grams, right? So 5 moles times the molar mass, 18.01 grams per mole. And 2 sig figs would be the rounding because 5.0 has 2. So 90 with the dot means 90 with 2 sig figs. Okay, that wraps up lecture 5.1. See you next time.